Hi guys, welcome back to the channel. In this video, we are going to discuss asynchronous 3-bit, 4-bit down counters. So let's get started. So in the previous video, we have already discussed about 3-bit ripple up counter and 4-bit ripple up counter. So in this video, we are going to just focus on 3-bit down, 4-bit down counters. Both are ripple counters only. So ripple means the previous output would be the clock for the next flip-flop. So these are all basics we have discussed in the previous video. Please check that video. So if you missed the video, I am giving that video in the description box. Please check it out. So in the down counter, we have two methods to do that. So for the first method is to take the outputs from Q0, Q1, Q2, the same outputs, the main inputs. But clock is passing from Q0 bar to the next flip-flop. So for the next flip-flop, Q1 bar is passing as clock to the next flip-flop. So in this way, by changing the clocks, by changing the inputs or outputs, only changing the outputs and the clock, we can able to manipulate our down counter. So this is the one of the down counter, the first method down counter. So taking outputs as it is. So you can also represent in the truth table like Q2, Q1, Q0. So that is MSB as Q2 and Q0 as LSB. The next method that we can implement the down counter is we can take the outputs, that is Q0 bar, Q1 bar and Q2 bar as it is. So without any hesitation, take directly the bars as output. But the clock you are going to pass as Q0 to the next flip-flop, Q1 to the next flip-flop. So here is a small change. I said before only, by changing the output and clock, we are going to have our down counter. So you can take the truth table as Q2 bar, Q1 bar, Q0 bar, because these are our outputs that we are taking. And the remaining thing as it is, that is MSB as Q2 bar, LSB as Q0 bar. So first of all, we need to understand the second method so that we can understand the first method, because second method is very relative or easy to do first. So if you observe the second method, we are passing clock as Q0 bar for the second flip-flop and taking directly output as Q0 bar, Q1 bar and Q2 bar. For that we need to have first of all, this is the truth table of the up counter. So in the up counter, in the previous video, we have already discussed from, that is MSB and LSB, Q2, Q1, Q0. So simply invert the truth table. So that is Q2 bar, Q1 bar and Q0 bar. For that inversion, we are going to obtain the mod 8 down counter. So this is the truth table for, or simply you can invert there. So 1 1 1 and basically you are going from 7 to 0. So that is mod 8 counter, down counter. So that is the meaning of down counter, right? Starting from the highest and we are going to the lowest, that is known as down counter. Now you can observe, this is clean observation. So with the help of the second method, we can have timing diagram analysis also to understand far much clear. So if you observe clear, we are taking the second method as Q0 bar, Q1 bar, Q2 bar as outputs. And you can see I took in the truth table also directly as Q2 bar, Q1 bar and Q0 bar. Just inverting normal outputs, we are going to have the inverted outputs. So these are only main outputs for the down counter, that is starting from 7 and ending from 0. So in the previous video, this thing has been already discussed. That is, if you have clock of 8 pulses, because after 8 pulses only our whole clock will be resetted as it is again to 0. So if you observe, this is Q0, Q1, Q2 according to the normal counter, up counter. It will count from 0 to 7, because for 0 to 7 is our 8 outputs, right? So as we are taking in the flip-flop counter, see the counter that we are taking outputs as Q0 bar, Q1 bar and Q2 bar. So simply invert Q0, Q1, Q2, that gives our output. Because we have already know up counter, just invert the up counter outputs, that gives our down counter outputs. So here is the thing, the first three are the up counter timing diagram analysis, that is Q0, Q1, Q2 for the first, second, third flip-flops in the up counter. If you see, just I have inverted both three of them, that is Q0 bar I have to Q1 bar, Q2 bar, because these are the outputs that we have taking in the flip-flop or the counter. So simply invert Q0, Q1, Q2, that gives our output. So we can also check that with the help of the truth table also. So we can verify this timing diagram analysis of 3-bit ripple down counter with the help of the truth table also. So if you observe, I labeled like this for the simplicity or clear understanding. So for the low level I marked as 0, for the high level I marked as 1. So there is a clean observation. After marking all the zeros and ones, you can observe that. So Q2 bar is our MSB, means we are going to start with Q2 bar. So 1 1 1 means I am reading from down to top. That's why I have segregated with red and black highlights colors of numbers. So if you see the first one, that is 111, that is 7. Next one if you see, that is 110, that is 6. So next one if you see, that is 101, that is 5. So likewise if you consider, that is a simple manner. means decimal manner, correct manner, that is from 7 to 0, and again going to 7 from the last one. That if you see the last one, that is again going to 1 1 1. So for the simplicity or simple understanding, I have drawn boxes also, you can see, observe there. So the first 3 corresponding to 7, next 3 corresponding to 6, next 3 5, like that. It is the whole pulses, square pay pulses according to Q0 bar, Q1 bar, Q2 bar gives our down counter. So basically it is going from 7 to 0, and again starting from 7 to 0, and again like it is continuously going, and we can say this is as mod 8 down counter. So what if you want the Q0 only, if you don't want the Q0 bar as outputs? So that is the first situation. So we have first only discussed about 2 situations. So now we are going to understand about first situation. So if you want the outputs as it is, means I want only Q0, Q1, Q2. I don't want bars for there. So simply you can take that also. So but you are going to take, or you are going to manipulate the clocks. So clock for the second flip flop is the Q0 bar. Clock for the third flip flop is the Q1 bar. Now we are going to understand this diagram with the help of timing diagram analysis, so that you can understand how this happens, how this performs as down counting. Now if you observe, now just starting with the first flip flop, the output is Q0. So if you see that I took directly clock with 8 pulses. So if you see the Q0, so this is the basic thing that we can get with the edge triggering. So if you see the first edge, second edge, I am going a transition over there for Q0. For the second edge, third edge, I have a clock transition from 0 to 1. So like this, I hope you know from transition Q0 how to build Q0, because this is basic how to build Q0 from clock we have discussed in the previous video. So if you observe the second, means the second flip flop, for the second flip flop we have the clock as Q0 bar. So because of having the second flip flop as Q0 bar clock, we need to have Q0 bar. So for that only simplicity, for the next step only, I am taking the Q0 bar. So simply invert Q0, we are going to obtain the Q0 bar. So this will be used as clock for the next one. So let's see that. But remember one thing, we have obtained Q0. This is one of our one of output for us. Next step is to find the Q1 in the second flip flop. So if you observe the cleanly the second flip flop, the clock is Q0 bar. So that is the reason I took the Q0 bar in the previous one. So take Q0 out, because that is our previous output. That is very important output that we are going to see in this video only. That is thing. So keep aside for the upcoming thing. So if you see Q0 bar, according to the Q0 bar, we are going to produce Q1. So Q1 will be going to obtain for each and every clock transition or clock edge transition. So that is the basic thing that we already know. If you observe Q0 bar, that we have clock transition or the falling edge there, that is in the second falling edge I took a clock transition of high. Then I hope you know how to do this. So if you clearly observe the third flip flop, in the third flip flop we have clock as Q1 bar. So for the third flip flop only we are taking the Q1 bar. So we have Q1. So simply invert the Q1 square pulse, simply invert that, we are going to obtain Q1 bar. So with the help of Q1 bar we are going to formulate the Q2. So keep aside the Q1 also. So the Q1 also is important because the outputs are Q0, Q1, Q2, right? So that is the reason we are going to keep aside our output Q1. So that is the same thing that I have done. So keeping aside Q1, because Q0, Q1 is our outputs. Next thing we are going to find the Q2. So if you observe for the Q2, the clock is Q1 bar. So we are going to have the clock transition for the 2 falling edges. So like that you can see over there for Q2. So I hope you know how to do that. Now we are going to just focus on Q0, Q1, Q2 and how it behaves as the down counter. So not just focusing on Q0, Q1, Q2, if you observe clearly, these are our 3 outputs finally. So in the same format, just arrange all the zeros and ones in that for the simplicity, or we are going to analyze this as this is the down counter or not. So if you observe that I have placed the low level as 0, high level as 1, so remaining all things would be the same. So now we are going to observe that first 3 are 0, 0, starting with 0. Next 3 are 1. Next after having 0, we are going to 7. So next 6 means 110, that is 6. Next going to 5, that is 101, like that it is going to down. So that is the reason it is down counter. So if you want to observe a clear cut way, this is the clear cut way of observation. So you can start with Q2, Q1, Q0. You can check all the conditions. So 0 0 0 is 0, so 1 1 1 is 7, next 1 1 0 is 6, like that it is going, so gradually decreasing. So starting from 0 ending at 1, basically decreasing, right? So 7 to 1, that is decreasing, again starting with 0. So you can also observe the sequence, that is 0 7 6 5 4 2 1, like that, again the same sequence continues. So that is the reason this is also a valid counter, so down counter. So I hope you understood the second method also with the help of timing diagram analysis. So in the same way, we are also obtaining the 4-bit triple down counter. In the previous video, we have already discussed about up counter. So the same way, nothing but just adding another flip-flop to that, our circuit, previous circuit. So there is two types we already discussed in the down counter. First one is directly taking Q0 as Q1, Q2, Q3 as direct outputs and taking clock as bars. As you can see, because this is the asynchronous one, we are going to have this kind of sequence. Q0 bar is to clock as next flip flop, Q1 bar is clock to the next flip flop, like that I am taking. So the next scenario in the down counter only for the T flip flop I am taking. You can also use just JK flip flop. So if you observe clearly, I took the Q0 bar, Q1 bar, Q2 bar, Q3 bar as our outputs, and passing clock as Q bar, Q1, Q2, Q3. These are our clocks. So remaining all things. This is the same thing as our JK flip flop or 3-bit down counter. So I already said before, you can also use the JK flip-flop for 4-bit down counting. So you can also see this is the implementation of JK flip-flop for the 4-bit. So I took directly here Q0 bar, Q1 bar, Q2 bar, Q3 bar in the JK flip-flop. So you can take the normal Q0, Q1, Q2, Q3 also, but by joining clocks with the bars. So that is a small change in the clocks and a small manipulation. Clocks and the outputs and bars, these are the small manipulation. So that if you understand once, it is very simple. So otherwise, just keep in mind one thing, that the remaining thing will be automatically by hearted or remembered by you. So just remember this thing, taking outputs as bars and passing clock as normal thing. So just if you remember this, the automatically reverse thing will be by hearted or remembered by you. So as I said, this is the same thing. I hope you can do the timing diagram analysis. It is nothing but going from 15 to 0. It is nothing a new change. So just adding the clock pulses, that's it. A new changes, nothing here new. You also saw in the JK flip-flop also. So just adding a new flip-flop, that's it. And increasing number of possibilities. I hope you can do this. In the upcoming video, we are also going to discuss these and all things for synchronous also. So stay tuned. I hope you understood this video. Thanks for watching up to now.